So we're going to talk a little bit about confidence intervals. Every time statisticians or scientists report um, any kind of average, they're always going to put it within a confidence interval. And there are several different types of confidence intervals, but we're mainly going to be interested in 95% confidence intervals, just because it's a nice standard and we don't need to learn a whole bunch of them. So let's look at this example. So Battery Park in New York City, the sea level rise over the last, from 1856 to 2006. Here's all the data. And that they've noticed that there's a 2.77 millimeter per year rise, but they don't know exactly what it's going to be, so they put it within a range so they make sure that it's right. They'd rather overestimate, give themselves a little bit of buffer. So they create this 95% confidence interval, and they say that that'll be plus or minus 0.09, and we'll work on how to calculate that confidence interval. So what they're really saying is that the true annual sea level rise will be between 2.68 and 2.86. So they're giving themselves a little bit of buffer, and we're going to learn how to do that today. First, we're going to talk a little bit about the theory behind it, and that states that if you have a normal distribution, right, which is unimodal and symmetrical, like these are, okay, this data is normal, it's unimodal and symmetrical, then we know that certain amounts of percentages of the data fall within 1, 2, and 3 standard deviations of the mean. So for example, here is the sample mean, okay? And here, this distance represents 1 standard deviation below the mean, and this would represent 1 standard deviation above the mean. And what they've noticed over time is that on average, 68% of data falls within 1 standard deviation of the mean. In other words, this area right in here would represent 68% of the data. Okay, within 2 standard deviation is around 95% of the data, and within 3 standard deviations of the mean, that would be 99.5% roughly. You can see these numbers are a little bit different, but that's the standard rules: 98, 95, 99.5. Okay, percent of the data falls within. Now we know that this point right here has a z-score of 2. That's working out really well there, because I'm trying to write with my mouse, I'm sorry. Okay, and this point right here has a z-score of -2. Okay, and so we know in between those two sets of data, there's a little more than 95% of the data. Okay, so that's kind of the foundation of it. So let's see if this holds true for the data that we know. Okay, so here's our mean is 14.9. Okay, that would fall about right in here. This was our average score for Ducky Chuck, and let's say that this is a sample where we're trying to predict what if we asked everyone in the school, our population, to do the Ducky Chuck thing. We're saying on average people would go about 15 feet. Okay. Now let's look what percentage of the data actually falls within 1 standard deviation. So this would be plus 1 standard deviation, and we know that because the z-score there is 1.02, so that's a little more than 1 standard deviation, because that's what z-score tells us. And this is minus 1 standard deviation, would be right here. So all these data points in here are within 1 standard deviation of the mean. Well, let's see if we can figure out what percentage that is. Well, there are 17 data points, and we divide that by 24 because that's how many total data points, and we would find that indeed at least 70% of the data falls within that, which follows that at least the rule says that at least 68% of the data falls within 1 standard deviation of the mean. Okay, And then it says 95% of the data falls within 2 standard deviations of the mean. Okay? We can check that too by saying, okay, so all of these data points down here are within 2 standard deviations because that is less than -2. And that is a little bit greater than -2. So there's 2 standard deviations below. Here's 2 standard deviations above. So we would add 1, 2, 3, 4. Then we'd have 23 out of 24. So then we can see that within 2 standard deviations of the mean, right, we have 23 data points, which ends up being a 0.96. So that's at least 95% of the data is within 2 standard deviations. That's an important distinction. So now that we know that, and how we use z-scores to figure out the proportion, the probability of percentages of data within a certain distance of the mean, let's actually find a confidence interval. Okay? So there are 2 conditions. One, it needs to be randomly sampled. All members of the population have to have an equal chance of being selected. Second, the data needs to be approximately normal. Okay? Let's look at that real quick. So if I go to my graph of the data, right here, we can say that though it's not perfectly normal, it is approximately normal. Okay? And so that condition is met. And so then what we're going to do is we're going to generate what's called a t-statistic. And we're going to look at the mean and create a confidence interval. 14. And so we need a few pieces of information. One is the mean. Another is the standard deviation. That's what this stands for. The number of data points. And then this t-statistic, which you have to look up on a table. And it's based on n. And the t-statistic we get from looking at the degrees of freedom, which is just n minus 1. So in this case, my n is 24. My degrees of freedom would then be 23. And my mean, or my standard deviation, was 7. Okay, now I have to go look up t on the table, and it's based on this number 23. So here we go. So as you can see, so I'll give you this table and a thing we'll give you tomorrow. On this side over here, this left column is what's called the degrees of freedom. Okay, so we're going to look down this chart until it says 13. Okay, which would be right here. And we're always going to look in this 95% confidence interval area. So we're going to go down to 13 right here and get 21.6 or 2.160. Okay. So we've got 2.16 is our t-value. Now we just plug it in. So we'll say the mean, which is 14.9, plus and minus 2.16 times the standard deviation, which is 7, divided by the square root of n of 24. Okay, so let's crunch that piece out in our calculators, and we will get back to you in just a second. Okay. So when I crunch all this, it ends up being 3.09, roughly. And so then we would say that we're 95% sure that the confidence interval ends up between 18.89, and apologize for that. So we would say that the mean, the true population mean for people chucking things with their feet without touching it with a hand, lies between 11.8 feet and 17.07 feet. and we would be 95% sure that the true population mean falls somewhere in there. So that's just an introduction. We'll talk more about it tomorrow.